Okay, today I'm going to attempt to remake my old triode video because in the meantime I've gotten a little bit more experienced in making triodes, and I just want to make a better video for you guys. The tube is still pretty much the same design as in the old triode making video. That's just due to the limited materials I have. It consists of 2 seals on each end. On this end, there's a filament made out of tungsten, and then 2 titanium ring getters. Then over here, there is a plate and a grid in sort of a half moon shape. And if we look close, you guys can see what it looks like. So you can see the plate on the outside, the grid, and in there, tucked inside, is the filament. So if you want to see how I make these tubes, be sure to keep watching. And at the end, I also show this one working in an oscillator circuit to prove that it's an actual functional triode. So, hope you guys stick around, because it sure is a blast. Okay, so we're going to start by making these seals. So I just have 2 lengths of copper wire right here for our 2 seals. Then I'm going to spot weld a tiny piece of nickel on the end of it. So as I've said in the past, this is to make the weld to the tungsten that we use for the seal, because tungsten wire itself cannot bond to copper directly. Let's just bend that around, and what you do is you put your cutters in there and you crimp it so it forms a cylinder. Okay, so now what you do, now you've got your nickel welded on there, you take some tungsten wire. I'm using 0.24 millimeter tungsten wire. And you take some like 200 grit sandpaper and like polish that to a mere finish so it's nice and shiny. And then you just weld this on here. Okay, then you take a dull pair of cutters. Don't want to use your nice sharp ones. Just cut that off. Now I'm going to repeat that process for the rest of the wires. Okay, so now all the pieces of copper have got some tungsten on them. So now I've got to prepare the steel that will go inside the tube. So I just heated this piece of wire in this piece of paper clip in the torch to drive off the zinc. And I'm just going to sand this to get a clean piece of metal. Then I'm just going to bend this into a horseshoe shape and we'll weld that onto the tungsten. Okay, so before we weld this onto the tungsten, we gotta flatten the ends just a little bit. Okay, so for welding the steel to the tungsten, you have to use a very short weld duration because you'll just burn right through it. That's probably about right. Okay, that's it. Okay, so now we're going to make the glass stems, I guess you would call them, that the wires are going to seal into. Okay, let's start the glass work. Okay, this is the flare holder. Just a bent piece of sheet metal with some slots cut in the end. Some standoffs down here. And what we're going to do is we're just going to flatten the end of this a little bit so that when we squish it down on the wires, there's sort of like a predefined squish direction, I guess you could say. Just pinched a little bit. Okay, so now we have to prepare the tungsten. What we are going to do is we're just going to pass this through the flame a couple of times. We're going to heat the lead wires as well to try to outgas them. Then what we're going to do is we're going to take a Q-tip with some flux remover and we're going to clean these off very well. We're going to heat them again in the torch one more time just to drive off the solvent, and then clean them one more time with a clean Q-tip just to get any loose oxide off of the tungsten. For what I understand, the oxide coating that we're after is one that is formed with a very intimate bond on the tungsten. I'm pretty sure if it's loose or powdery on there, when you seal it in the glass, that oxide will just separate and it will create sort of a hollow void between the tungsten and the glass, which will create a leak. It's just going to Okay, so I'm just going to heat that up in the flame one more time. So now with a dry, clean Q-tip, I'm just going to give one more wipe. Get anything that's loose off of there. Okay, that's what the seal is going to look like. Okay, so an important point about this, when I'm pitching this down, you can look inside there, and it's important that the copper wires are not touching the inside of this until they reach this bottom point right here. So how this works is these sort of fold in on the side, and they clamp down there. And that leaves a stretch of the copper wire that's not touching anything. That's important because the copper acts like a heat sink, and it will suck heat away from the seal and keep it from getting hot enough to make a good seal. And this needs to be really hot in order for the glass to make the proper seal to the tungsten. So what I've done is I've just pinched the glass on the wires, Now what I have to do is I have to heat this seal incredibly hot and then pinch it again. Oh, that sucks. It was out of focus the whole time. I'll have to get you guys a better shot in the light, but the seal color does look good. Okay, so that's a good seal color right here. Yellowish to coppery color. About like a copper orange is a good word for it. Orangey yellow. Okay, so now we can start on the internal tube elements. I'm going to use this piece of metal for the plate, and for the grid I'm actually going to make the grid this time. So I'm going to use this copper wire for the supports, and I am going to weld on nickel wire to form the actual grid elements. So you want the grid to be a little bit longer than your plate to make sure that the plate is fully shielded from the filament, to make sure that the filament does not have an unobstructed view to the plate, or else you'll have a parasitic diode. So maybe about there. And can always cut it shorter later. Okay, that's going to be too big. So what the plan is I'm just going to weld on the nickel wire straight, like this. And then once I'm done, I'm going to snip this piece of copper off here, and then I'm going to bend the grid around something round to make like a half-round type shape. So that's just going to take forever, so let's get started. Okay, so this is going to be tough, because copper doesn't like to spot weld very well. I'm hoping the nickel will sort of compensate for that, but this could just go horribly wrong, so let's just see how it goes. Oh, I'm using 26 gauge nickel wire. Thinner wire would probably be better. Yep, this is probably not going to work. Okay, gonna have to come up with a different plan. Okay, so that copper welding attempt to the nickel was a complete fail, but I kind of knew that was going to happen. So I'm going to try out Simplifier's metal plating technique here. So right here I just have 2 clumps of nickel wire in vinegar, and that's just electrolyzing at like 15 volts or something. And I'm going to let that sit for a little while until it's like a green color, and see if I can try to electrolyze that copper I have. Okay, so I've had this cooking for about an hour, and if we look at the negative electrode, actually you can see some crystals on there. So I think this thing is ready. So I'm going to take this and I'm going to wipe it off with some sandpaper and then dip it in a little bit of vinegar to clean it off, and then we can try to etch it. Oopsies. Okay, just gonna let that soak for a little bit. Okay, so I had this soaking in the vinegar for a little bit, and I've decreased my supply voltage, because I think on his page he mentioned that he electroplates at a much lower voltage than the voltage he used to set up the solution. So I think I'm just gonna sit this in here and let it soak for a while. And I'll get back to you after this has been in here for a little bit. Okay, so it's been in there for about 20 minutes. Let's take it out and take a look. Okay, that definitely looks shiny. I have to see if it spot welds any better though, so let's give that a try. Okay, so here's a better look at the nickel plating. Just a piece of plain copper down here, and you can see the shiny metal on the top. Okay, so I'm just going to weld some wire down here to keep it stable while I do the fine welding. Oopsies. Okay, that seems to weld fine. So let's try the nickel. Yep, I think that definitely fixed our problem. Ah! Okay, just going to give this a weld here. Okay, that does definitely seem to be a better weld. A lot stronger than the weld directly to the copper, definitely. Okay, so I'm just going to spend the next half an hour welding these strips on here. Okay, so I got that all done. It took a little while, but it wasn't too bad. So, now I gotta get things sort of bent into shape. Okay, so I'm gonna get rid of this by just breaking the spot welds right here. And I have to be careful up here, because when I cut, it's possible that the force from cutting is going to distort this. So I have to be careful. Okay. So let me get something round. I can bend this around. So I have this punch right here. Now I'm just gonna that's going to be our grid right there. Maybe bend it just a little more. Okay, so the plate and the grid are going to be oriented like that. You see we have a little bit of extra there to make sure that the plate is fully, the filament is totally enclosed. Okay, I think we're ready to attach those to one of the stems. Okay, so for the electrode arrangement, I'm going to copy from this other tube I made. This was one of the more pretty ones I made. And you can see down here, we have one side that's bent over like that to weld to the plate. And this one is just pretty much tied straight to the grid. So I'm going to copy that when I bend these. That's a good looking one. Okay, so the grid I'm just going to weld on the side there, so I'm going to cut this side of the grid off. Okay, so I'm going to cut some more off of here. That's just going to weld on like that. Okay, that turned out good. Okay, so now we're going to weld this plate onto a piece of wire. Okay, so I have the plate about ready to be welded. Just have a wire stuck on there. And I'm just going to weld that on right there. And I will have enough length right here to bend the plate into whatever position it needs to be. Okay, so that's the finished plate and grid assembly. Now we probably should start on the envelope. That's probably what we should do next. Okay, so here's the glass I'm going to use for the envelope. I'm just going to make a few marks about approximately where I want the glass to be blown out. So I just have this titanium piece of titanium in this pin vise, and you can use that to draw on the glass. That just gives me some spots to aim for when I'm blowing it out. Okay, that's going to be our envelope. Okay, here's the envelope. This is really starting to take shape. That's going to look really good. Okay, so now we have to start on the filament assembly. And we're probably going to have to cut off a section of tubing down here because this is just too long. Okay, so you can see that that is just too long of a stem down there, so cut off maybe 3/4 of an inch off the end. For cutting off pieces of glass this short, I don't have enough length right here to give it a good pull and bend. I just don't have the length there. So what we can do instead is we first wet this, and then we heat up a piece of glass very hot and press it up against this score line, and that should crack it. So let's give that a shot. Okay, just like that. That easy. Okay, so there's a little bit that got chipped out right there, but when we heat that with a torch, that should all pretty much even out. Okay, so it's going to go together like that. So I'm going to leave the top part of the metal of this stem right here, and I'm going to cut the bottom piece short and bend it over so we can mount the filament on there. Okay, so we're still going to have to extend the top one a little bit. So what we're going to do for this is we're not just going to have this piece be straight right here. We're going to put a curve in it, and that gives us some extra room to bend this lead up or down to put the proper tension on the filament so it avoids it collapsing due to heat and touching the grid. Okay. Okay, so I have some 0.11 millimeter tungsten wire, nice and thick. Probably use like an amp or so of filament current. That's going to be our cathode. Okay, so I still have to put a getter on the filament stem, but I think we're ready to seal this chop joint in. So let's get on that. Okay, so before we seal this in, I'm just going to let it soak in some acetone for a little bit, just to clean off any fingerprints that are on there. Okay, so after this, I'm just going to heat it up a little bit in the torch just to drive off any acetone, and then seal it in the glass. But it's important not to touch this after doing this, because we'll get greasy fingerprints that will outgas in the vacuum. Okay, about ready here. Okay, that turned out a little bit messy. But I think it's sealed. It looks relatively straight on the inside. I might have to tweak that a bit, but we'll take a closer look when it cools. Okay, so I had to heat that up again to move it more in the center. But that looks like that's going to work great. So I think while I'm at it, I'm going to attach the evacuation stem on there as well. Okay, it's sealed, but it sure looks ugly. You really don't need to anneal Pyrex, I just do it for some reason. Okay, so that should be this section. This section of it is pretty much done. I just have to finish up the filament stem and get like a getter on that. Okay, so for the getter, I'm going to use titanium wire, and I'm going to put 2 loops in there just for just a little extra getter material in there. You want it as big as possible, but not so big that it won't fit, obviously. And if this is too close to the glass, it can tend to crack it, because you heat this up to white hot with the induction heater so that it works, and that can screw up the glass. Very quick spot weld there. Now just repeat that for another loop. Okay, so to weld the titanium on there, I'm going to wrap another piece of nickel around here and weld it on there, because you can't. Titanium really doesn't weld very well. Okay, just have a little piece of nickel right there. Okay, that should be done. Okay, so I took this out of the acetone, and I'm just going to heat this up a little bit. Okay, so I'm just going to clean that tungsten off a little bit with a Q-tip, and then we'll seal this in. Okay, time to seal this one on. Okay, I think that might be it. Gonna let that cool and see how things are aligned. Okay, so this is the finished tube. Now we have to put it on the vacuum pump and check for leaks. It doesn't look like we have any leaks. Okay, so I'm just gonna let that pump for a little bit and heat it. Okay, so I have the tube on the pump, and I'm going to see if I can get a little life out of it with the tube tester. Okay, looks like we got a little transconductance there. It's a little erratic right now. Okay, it seems like this might work if we can get it sealed off and nothing bad happens. It is jumping a little bit though. So this is plate current, transconductance, grid voltage, and plate voltage. And this is filament voltage. So if I give it just a little bit of negative grid voltage, it turns off. This is the signal being fed into the grid. And that's the plate voltage. Okay, I'm going to attempt to seal it off. Okay, that should be our finished tube. Okay, so I have the tube hooked up to the tube tester, and now we're going to see if it still works. So I'm going to give it some plate voltage, and give it some filament. Okay. It is passing current through it, but not much. And the... Oh, geez. Okay. I think this has a little bit of gas in it. I'm going to try to hit this with the induction heater to flash together again. Wow, look at that. Yeah, so I think I read something about this on Simplifier's website. If you have just a tiny bit of gas in a triode tube, but not quite enough to where it acts like a thyrotron, you can have states where it has very high transconductance. So right there, that's a lot higher than this should be. It should be between about -20 and -10. So this definitely has some gas in it. Let's give that a shot. So I think unfortunately that might just be all we get out of this tube. I think it just needs a higher voltage in order to pass a lot of current through it due to the fine spacing of the grid elements. Oh wait, no, there's another possibility. It's possible that the filament shorted to the grid. Let me get a magnet. Nope, so the filament isn't shorted to the grid. I just have the grid spaced too close together. So right now I have the anode connection just tied to the grid. If I give it some filament, I get a whole bunch of current. So I think we just got to live with what we got. So I'm going to try to make an oscillator circuit out of this and see if I can get it to work. But I think I just have that grid too close together. Okay, so we're going to really quickly slap this together. We're going to make this Hartley oscillator. And I have this coil I made. And we're just really going to quickly just like tack all the wires together really sketchy just to see if we can get this to work. Okay, so I have this triode hooked up in this Hartley oscillator circuit right here. And I have this little transistor radio nearby. That should pick up the signal from this if it is oscillating. And I also have the oscilloscope hooked up so you can take a look at the signal and figure out what frequency it is. So let's give this some filament voltage. Okay, we have radio silence. And there's the waveform, about 780 kilohertz. So let's see what that looks like if we reduce the filament. Okay, let's try to tune around a little bit. Okay, we max out about 1 megahertz. Looks like we die out at about 500 kilohertz. So, I think that is it. This tube is working as an oscillator. Even though we had very low plate current, like less than 1 milliamp, which is pretty sad, we were still able to use it to build an oscillator circuit. So, I think that is a success. Thank you all very much for watching. Okay, so I thought I would give you guys a reference for how one of my tubes normally tests. So here's another tube that I made recently, and this one has a much less restrictive grid than the one I just made. If I give this some filament voltage, you can see we have a transconductance between -20 and -10. which is about normal for the tubes I make. If I decrease the signal going to the grid, you can see that goes away and the plate current rises. And if I give it some negative grid voltage, the plate current goes away and the transconductance goes away. So that's sort of what I want to see. I'll also show you guys this one as well, because this one turned out particularly good. Okay, so here's that other tube I recently made. It looks a lot similar to the one I made in this video, but this has a much more open grid. So you see this one has a much higher transconductance, and that's partially related to this. It just has more current passing through it. Because, like, it's hard to really get a true transconductance test and have it completely independent of the current. So you see that one really kicks ass. So that's a very, very good testing tube right there.